Last time we left off taking a look at the exponential properties. And let me flip back a couple of slides just to remind you of some of them. In fact, we'll go back up here a little bit of ways. We had all of these properties that we talked about, and then I sort of proved to you with a little bit of case examples why they work or how they would work. And we had done a couple of examples of how they're used. So we're going to pick back up. This is the last examples that we had done on simplifying them, writing with positive exponents. And what we're going to do now is we're going to take that same idea and we're going to simplify something and then solve an equation. So this is an equation because there's equal signs, and then part B is an inequality because we have an inequality sign. All right, so our goal is on the left-hand side to somehow combine them so that it is a single exponential expression. So the left-hand side of this one right now, I've got 2 to the n and I've got 2 to the 7. How can I combine those together? All right, and I still need that base of a 2, right, Sarah? Yeah. Right, so I've got 2, and then I've got n plus 7 as my exponent. Now, what I need on the right-hand side is I need that also to be written as a base of 2. What I need is I need to figure out what has to go right here so that this right here will equal 64. So you can play with your calculator and try some powers. You can maybe remember that one, maybe you don't, but we're just looking for the number that we should use as the exponent. Okay? So take a guess. What do you want to try? 6. So take your calculator, and on your calculator I want you to see if 6 will work. So you'll put a 2. You've got a button that probably looks like a caret. I've got a keyboard, it's called caret. So you use that button and then put in 6. What we're trying to find out is if that value is the same as 64. Okay, so a couple of you tried your calculator so far. Sarah, it worked, right? Did yours work? Jennifer? No? Does it work with you, Audrey? Find the caret key. Sometimes there's a button also that looks like, scientific calculation, let's see what they look like. The y to the x is the one you want. Sorry about that. That's sometimes what your button will look like instead of here. Did you find it? It does. Yeah. Okay. So did it work? Did 2 to the 6 work out to be 64? Okay, so it's just a little trial and error. That's okay. There's no problem with trial and error. It's not cheating. So we're going to write that as a 6. Okay. So why do we want that to be the same? Well, if the bases are the same, they both say 2, then we can only look at the exponents and they also have to match, right? In other words, this means n plus 7 must equal 6. If the bases match, which they do, they're both 2's, then the exponents also have to match because this is an equation. It's got the same on both sides. So what would I do then to solve n plus 7 equals 6? I subtract my 7, right? And what does n equal then? -1. So that is my solution, n equal -1. Any questions on that one? Process on part B is the same, but it looks different for 2 reasons. Reason number 1, I've got a less than or equal to sign instead of the equation. I don't have equals, right? That's just semantics. That's just simple. It's not a big deal. What else about this makes it look tricky or different? Yeah, fraction, right? I didn't have a fraction on the one before. So I want you to ignore the fraction for the moment and just look at the value of the bottom of the fraction. And I promise we're going to deal with the fraction. We're just going to ignore it at the moment. I'm going to take this 81 and I'm going to try to write it as 3 to some power. Okay? So what power needs to go in there so when I do 3 to that power, I get 81? 4 will work. Again, you can use trial and error with the calculator. 3 raised to the 4th and it's going to equal 81. So this is almost like what I want, isn't it? I almost have 3 to a power on both sides. to change it so that it's in the denominator, it's not in the denominator. Make my exponent negative. That's one of our properties, right? If my exponent is negative, it can be put down in the denominator as positive. So I'm just using the property in reverse. I'm pulling it back up to the numerator and then make my exponent negative. Okay? So then this becomes very much like it was on this problem at this point. I've got the same base on both sides. So I can now focus exclusively on the exponents, n and -4. And the symbol just carries straight down, just like the equal symbol did right here, right? It's not an equals because it didn't start out as an equation. It wasn't equals to begin with. It's still less than or equal to symbol from prior. Make sense? Okay. All right, we're going to do a little bit of approximation. I've got them in the wrong order, so I have to fix that. So to approximate the following, so if you were dividing 20 and 1/3 by 9 7/8, what would you change 20 and 1/3 to? What would you change 9 7/8 to? So that they would divide nicely, cleanly, so that it makes the problem easy. What would you do? What would I like to change 20 and 1/3 to? What would I like to change 9 7/8 to? So that the division is easy. 3 and 10, sure. And that's really close, right? 20 and 1/3, I'll change it to 20. 9 and 7/8, well that's nearly 10. And I like those two dividing because they divide easy, right? Easily. So the 20 divided by 10 is 2. And you're awfully close. If you took your calculator and you told it 20 and 1/3 and you took the division and you divide by 9 7/8, you'd be really close to the value of 2. And sometimes approximations are good enough, right? So this is one of those things you're going to be taking a look at. So approximations in this section. Example number 9 is a little bit different. So we've got Jasmine, she's reading a book, and she's finished 3/4 of it. So one of the things that you might look at it and think from the perspective of when you guys have read books as you were growing up is, well, how did you know she was 3/4 through? Well, this seems sort of silly kind of question. She would have looked at the page number or anything, right? So it seems like a dumb kind of question right now. But think about the direction we're going in reading books these days. Does anybody have an iPad that they read on? Or a Kindle or a Kindle Fire? They've got other tablets now too, like Nexus. All these tablets that are out, these iPads, these things where you download a book and do it electronically, or maybe you just do it on the computer itself, right? Do they tell you page numbers? No, they don't. In fact, mine will tell me that that's the bar at the bottom and it says you're 78% done, or something like that. So it doesn't tell me in fractional form, but it does tell me in percentage form. So that'd be the equivalent of saying that I had finished 75%. 75% is the same as 3/4 of the book. So sort of imagine that's what's going on here, okay? So we've got a 3/4 book, and then we also know that it's 82 pages. This is an exact representation, but I'm giving you an idea here. 3/4 of the book, and she has 82 pages left to read. How many pages has she read? And there's several ways to do the problem. So as you think about it and look at it, what do you see? A proportion would work. We haven't exactly got any proportion, have we? We'll get there really quick though. I think 6.4, we're on two proportions. Yeah. That's one way to set it up. Anything else? There's a really clean, easier way to do this. You're just letting out. So, if she's finished 3/4 of the book, Okay, so if I did 82 times 4, what's that going to tell me? What's that? How much the whole book is. All right, that's true. So if I took 82 pages times 4, I'll end up getting the pages of the book. Okay. So what would that be? 328. 328? Did that answer the question? Not quite. What did the question actually ask? How many she's read? So what do I do next? All right, because that's the part she hasn't read yet, right? So if I took 328 minus the 82, what would I get? 246? And that would be the pages she's read. Okay, so to be honest, this is how I think about the problem as well. I do it in proportion. Yeah, sure. Of course. We just haven't gotten there yet, so I want to avoid doing a proportion that I have to show you to do. Yeah. You're fine. You want to do proportions.
I was expecting another way to do it.
There's an even easier way to do this problem, though. My students last semester were the ones that said, well, let's just do that. And I thought, oh, so you do that. So if she has read 3/4 of the book, and she only has 1/4 left, then 1/4 of the book is equal to 82 pages, right? Yeah, 1/4 is equal to 82 pages. So how can I find out also another way of how much 3/4 of the book is? 82 times 3. So 3/4 of the book is simply 82 times 3. It's nice because it's only one step. I only do one multiplication instead of multiplying and subtracting. Yes?
Could you do example 8 like for real, like how you really do it?
Well,
I know.
it's not asking you to really do it. If you were asked to really do the problem,
Yeah, like how would you
the first thing you'd have to do is to turn these both into improper fractions. So you'd end up with, this would be 61 over 3 divided by 72 plus 7 would be 79 over 8.
And you just flip it.
And then you flip it. Yeah.
You just pick that off.
Yep. And then you'd have to simplify it back into fractional form, mixed number form. You can start out in mixed number form. Yeah. It doesn't look very nice, does it?
No, I was just making sure.
Yeah, but that is the process you'd go through, definitely. Okay, so this example 9, there's lots of ways to do it. So I did it 2 ways before, and Sarah keeps telling me she wants to do proportions, which I promised her to do proportions, but which would work fine too. There's not any guidelines given on how you do the problem, right? And to be honest, I don't even do it quite like what's written on the board. I would actually put it in an equation form because I think about equations because I'm a math person, right? So I would actually set up an equation. And my equation would look something like 1/4 x equals 82. That's what I would do. That's what I'm inclined to do. That's what you were saying. Genetic proportion, that's what I see. So I want you to be aware that there isn't really a method that you're having to use here. There's one more here that I want to take a look at. And give you a chance to think about. So we've got Al, and Al gives half his marbles to Bev, and Bev gives half of these marbles to Carl, and Carl gives half of these marbles to Danny, and Danny was given 4 marbles, so how many did Al have originally? So, and again, the issue is, there's not a way that was given to you if you have to do this problem. One of the methods that is discussed back in chapter 1 of our textbook, which is taught in Math 1, and again, you don't have to have that to get here at this point. You've seen this method before in your mathematics. It's this idea of working backwards. And working backwards works just beautifully in this case. So let's take a look at that. So I'm going to show you this problem. Again, it's not the only way to do it. The one really nice way to do it is to work backwards. So we're going to start with Who's the last person? Danny? We're going to start with Danny. Danny has 4 marbles. But she received those marbles from Carl, right? So Carl originally had how many marbles? 8. Before he gave them away, before he gave half away, yeah? So, but Carl received those marbles from Bev. So how many did Bev have before she gave them away? 16. Again, we've got the same sort of argument here. I'm not going to write it again, but we have Bev. And then we have Al. So how many did Al have? He rather had 32 yet.